Okay, next part of the question. The function g is defined, so the range is all of the real numbers, by g of x is equal to the integral 1 over root 1 minus 2xt plus x squared dt. Again, by evaluating the integral, sketch the curve. So we're going to assume this is the same sort of question as the one we've just done, and so we need to do a substitution. So let's do u is equal to 1 minus 2xt plus x squared. I could make the integral u squared. I could. Or I could make it u. I'll just make it u. That'll be fine. Du by d. So same principle as we just did. This time we've got minus 2x here. Yeah. So x once again isn't part of the. We're not interested in x in the integrand. We're integrating with respect to t. So just treat x as if it's a constant, and then once you've worked out what the integral is, then x becomes a variable again. So du, so minus du over dx over 2x is dt. So 1 equals t minus 1 equals t. I'll make that the same at the moment. Root u times minus du over 2x. Okay, so bring the minus 1 over 2x out. T is 1 and minus 1, u to the minus a half, sorry, u to the half, du. Integrate that, so minus 2x, 2, sorry, that was minus half, I was right, 2u to the half, and its t is 1, negative 1. Okay, let's make u back again to what it originally was. So, well, I can cancel the 2's here, right? So let's get rid of the 2's. And we've got, what was u? 1 minus 1 minus 2tx plus x squared. And that's all to the half. T is 1 and negative 1. Minus 1 over the square root of, okay, if t is 1, we have 1 minus 2x plus x squared, which is 1 minus x, all squared. And then when t is minus 1, so it's plus 1 over x. T is minus 1, we've got 1 plus x, all squared. Let me write this another way. So this is 1 plus x squared minus 1 minus x squared over x. Now, how many of you are tempted here, or were tempted if you tried this before, to just say that this is equal to 1 minus x, and this is equal to 1 plus x? Okay, if you haven't done this yet, and this is the first time you've seen this, stop the video and figure out why this doesn't work. I'll give you a few seconds to pause the video and think about it. Okay, now I'm going to explain why. It's because this is actually one of the definitions of 1 plus, mod of 1 plus x minus mod of 1 minus x over x. Okay, so we've got to think about what the mods might mean here. I mean, you don't have to write them as mods. You could just keep them in this form above. but you have to be careful because it might not behave quite how you think. Okay. So how do we deal with mods like this? Well, what we do is we split our functions into 3 separate conditions, right? This one, and this one. It's important to get the high level structure right here. So and we split this into different regions, right? So the first region is x is going to be less than -1. The second one is going to be x is between -1 and 1. The third region is going to be x is greater than 1. Okay? Because these modulus functions behave differently in each of these 3 regions. Now, is there another definition of a modulus function that we can use? There's the one I like to use, which is, I'll write it out here, mod of x is equal to x when x is greater than or equal to 0, and negative x when x is less than 0. Okay? So think about this for a second. If mod of 3 is greater than 0, so that's just 3. Mod of -1 is less than 0, so that's -1, which is 1. So this always flips the sign. Okay? Back to our 3 conditions. I'll do them in different colours, shall I? Let's do them in different colours. So we've got the red one first. When x is less than -1, uh, 1 plus x is negative, and 1 minus x is positive, I think. Yes. Which means mod of, let me just check, 1 plus x minus mod of, it's 1 minus x, yeah. 1 minus x is equal to, I'll do it beneath, is equal to minus 1 plus x minus 1 minus x. Okay, so the sign of this has changed to a negative, and the sign of this is a positive. And obviously, because there's a negative here, it becomes minus and not plus. Okay? So that is equal to minus 2 plus 2x. Wait a sec, I've obviously made a mistake here. That's 0, it's minus 2, yeah, sorry. So it's minus 1, minus another 1, which is minus 2, and then minus x, and that's plus x, yeah. So in this case, f of x is equal to negative 2 over x, right? Because we've got this x on the bottom. Here, we've got this x on the bottom. Okay, next condition. X is between those 2 poles. I'll do this in green. So let's copy the last line. So 1 plus x, in this case, is positive. And 1 minus x is also positive. So effectively the mod signs just drop off. So mod of 1 plus x minus mod of 1 minus x is equal to 1 plus x minus 1 plus x. So the 1's cancel this time, and we end up with 2x. And so f of x is just 2. And the last condition, the blue condition, 1 plus x is positive, and 1 minus x is now negative. So mod of 1 plus x minus mod of 1 minus x. 1 plus x is positive, so the mod signs just drop off. 1 minus x is negative, so it becomes plus 1 minus x. Yeah, flip this sign here. So the x's cancel, and it gives me 2. So f of x in this region is 2 over x. Okay, so now I have 3 conditions and 3 graphs for each of those conditions. So it's time to sketch them. Do this in black. Right, I don't know what this is going to look like, so let's... So this is x, this is f of x. Okay, so we'll do each bit in green. When x is between 1 and minus 1, we have f of x is equal to 2. Like this. Minus 1. 1. 2. When... Get my blue pen up. When f of x is greater than 1, we have 2 over x. And when x is 1, this equals 2, which is this point here. So we have the 1 over x, or the 2 over x graph, which looks like the 1 over x graph. So asymptotic at 0. And then, because this is minus 2, it's going to be... Is it going to be the same? When x is minus 1... Yes. When x is minus 1, this is 2. And it must be asymptotic. That doesn't match. There we go. Like this. So let me zoom out. That's my graph. Okay, so this was the tricky bit, really. Remembering that this is a mod, and then splitting this into 3 conditions. Let's get your graph. Excellent.